This is my code review for CS 499 for my software design and development project. I will be using a project from one of my previous classes where we were using Jupyter Dash to create a GUI interface to provide customer with animal shelter, and then based on what the customer needed on rescue type animals and what he was looking for in this project. And in this method, some of the things I see first, or still I have these fixed me's. You can take these out, create better comments as to what the code is actually doing. There's still a few fixed me's. I guess a little bit more about the layout of the design first, as that's what I will be doing. The layout uses HTML and Python dash Jupyter. We have our basic header, and then we center it on the dashboard. Then next we have our radio items, or radio buttons that are labeled water rescue, mountain rescue, disaster, reset. And then value, originally it says reset in our HTML rows. Then we have our data table. Data table gets pulled from MongoDB and brings up all the information or everything from the records. Again, actually we can see these fixed me's. These can be taken out as we are going to redefine and just show what all these basically are doing. Editable, true, filter action, so forth. And then in this, there was graph and map ID, but we won't be focusing on this for our enhancement. Alright. This section right here goes more just towards the database side of it, which we will also be enhancing. For our rescues, we have callbacks. One is the update chart for water, mountain, disaster, reset. And this is all based on, for the project, what the customer needed. So what we are doing is querying the database, using our statements, what the customer is looking for these rescues. Again, we are querying the data frame that was returned up here from our main data frame record. And we're returning these. A little bit more about the project and a little bit of the enhancements that we will do. First and foremost is username and password. Our end text. We'll be creating a WPF application to first redo this layout or make a similar layout to having label IDs and our data frame records to be showed. In order to edit the data table or data in those tables, those records, what I will be doing for security reasons is updating or creating a login screen for user and user password. Along with this, I will also be creating more or less user roles to have differences in what and how much they are able to perform, which brings us to our next piece of the project that it goes along with this is our database. Along with database, we're using MongoDB. I do not have this, so I will be, again, with the WPF application using SQL Server. And this is also to show that the same project can be done in a WPF application and shown not only done in Python, but also in SQL syntax. And this, we have our connection, which will be attached in the WPF as a standalone software. We have our create, which is our insert. Be able to create new animals based on values, and each value will have its own text box. So we're not questioning what data is available or what is necessary. There will also be an exception for the insert records to make sure that no two animal IDs are similar. They will need to be unique values. Our read method, again, we can see some code that was used for testing. This could be removed now that we have our final code in place, and simply describe what this code is doing. For this is a read method, return search, and it returns. For testing, it was still limit 1000, but we can keep that there. Again, old method that returned this can be deleted as it is no longer necessary and was only used for testing. Our update method, again, we have more code that doesn't need to be there, kind of clutters up the entire view of what's actually happening, which is the result right here. Self-update, search and update. Right, then we print just to be sure that the records were updated. If true, return true, records updated. Else, check record to update. And our exception, record not found. And then finally our delete method. Again, code that can be redone and revamped or removed, as this is our actual method for deleting the data. Self, return, and then print to make sure that the record was actually deleted. This will all be done in our CRUD methods for database. What I'll be using is store procedures to reflect on the create, read, update, and delete. And then this is where also there will be a user, so we can keep the username and password, a user table that will have roles, and based on those roles we'll provide the user with either credentials. More so everyone can read, but only a certain group can create. Certain group can create and update. And then final, to make sure nothing gets deleted unless actually required. Final, more or less admin permission, has all the CRUD methods including delete or high level management. These two projects will consist of our software design and development, as we will be using, again, the WPF application to show that this can be created also using other softwares. And again, our database project, as we will be querying our databases for these. These will all be store procedures against the database that when clicked on a button, it will return in a data grid. For data structures and algorithms, I will be using a project done in computer graphics and visualizations. This uses a source known as OpenGL to work with your GPU to display graphics to the screen. Most of these are crossed out only because these methods are not put into Visual Studio. This is just for display purposes. Little bit about the program. We have our window height, width. We have our basic mesh, VEL for vertex object arrays, and vertex buffer objects, number of indices per mesh. We create our windows, we create our program ID, our camera, our delta time, let's see, our object colors, light positions. Then we have our user-defined functions, process input, mouse callback, mouse scroll, create mesh, destroy mesh. We have our shader source to also use for vec3 position. Vec2 is texture coordinate, vec3 normal. Our vec3s are 3 position X, Y, and Z. Vec2 for texture coordinate is only for the surface level of that object, thus only requiring 2 vectors. And then of course our normals is that plane in the center, but also requires 3 vectors: position, texture, and normal. And then we have those going out. Our map 4 is for our model, our view, and our projection. So this is where we can see what is presented to the screen. Again, position is projection, view, model. For our fragment shader source, we're inputting these variables and then outputting our fragment color. This right here is also working with ambient. Strength is our lighting strength, calculating distance between lights and light direction, intensity, light, reflection, and so on. Fragment colors. Again, this will be using a lamp. Right now, the lamp is stationary. More on that in just a bit. Well, our lamp is stationary. What the enhancement will be is to make the lamp rotate around the pyramid. Using delta time and our algorithm. Our main, this is where most of the program happens. Initialize mesh, create the mesh, input our shaders, create the shaders, create the texture, use the program, use the location, clear color clears the screen, and our window opening. Again, for data structures and algorithms, we are using delta time, and then last frame equals current frame. This will also be used to help us visually see the lamp moving around in a circle, also with our controls. here in just a second. So what we can see is after everything has been processed, we then destroy our mesh, destroy our texture, and destroy our shader programs and exit successfully. And this is for windowing and for our display. Alright, as far as delta time, we have our process input, which for our camera speed 2.5, and then we have our window key functions. Escape returns closed window, W is forward, yes, S is backwards, A is left, D is right. Alright. Then again our mouse positions, mouse scroll, callback, mouse button clicks, which are not really implemented other than to say that you clicked the mouse. Break. Alright, render is where we are rendering the object. Clear color, bind our vertex from our mesh vertex array object, and again use the program. Right here we have our object, which is scaled, rotated, translated, and our model. Translation times rotation times scale. We also have our camera view and our perspective. We have our color and our light color. And then right here we have activate texture. We pull in our texture, bind a texture, and we draw the arrays. In this case being triangles. And this is our lamp program, lamp ID. So we have, again, using model, view, and projection, our matrix uniforms, pass matrix data to the lamp shader programs matrix, and then our triangles for our first lamp. And here are our objects. First we have the position, which is our points of reference for a pyramid. Each side, bottom, front, left, back, and right. And then we have our texture coordinates and our normals. And this brings everything together. Floats per vertex is 3, which is right here. Floats per UV is 2, and our floats per normal is 3. Then we do our calculation, floats per vertex, plus floats per UV, plus floats per normal. We have one mesh, vertex array object. We bind the vertex array. We create the buffers, stripe between vertex, create vertex attribute pointers. And then as we move along down, we have our destroy mesh, our method to destroy mesh, the create texture, our destroy texture, and create shader program. All in all, what I would say is this code is decently commented as to show what each piece is doing. I wouldn't say that there's too much needed in the way of commenting in this, as most of it is clear, most of it is needed, and can be easily deciphered as to what's going on in this program. All methods are named easily to where, such as here, create texture and use program and clear color. Should window close. Again, for data structures and algorithms, I will be using this. The enhancement will be to add the logic or algorithm to have this lamp rotate around the pyramid instead of just remaining stationary. This will include delta time and our reference and degrees of angle to be rotated around the pyramid. That is my code review. Thank you for watching.